Hey everyone, and welcome back to AI Paper Podcast. We're going to be breaking down some fascinating new research today.
Yeah, it's always exciting to see where this field is headed.
Absolutely. And today we're diving into something that I think a lot of folks in the AI world have been grappling with. How to make those large language models think more efficiently.
You know, without sacrificing accuracy, of course.
Exactly, because we all know what happens. You spend all this time and compute power training an AI to reason step by step with chain of thought prompting.
Oh, yeah.
And then
it just dumps this massive wall of text on you.
Right. Even for like a simple problem.
It's like, okay, I just wanted the answer, not your entire thought process.
It's not exactly elegant.
Nope, not at all.
And that's where this paper comes in, this CoT-Valve, Length-Compressible Chain of Thought Tuning paper.
Oh, yeah, this one's interesting.
It's like they're offering a solution to finally control the length of these reasoning chains.
On the fly, too.
Yeah, dynamically.
Which is pretty cool.
It is. And the funny thing is they started with a really simple observation.
These researchers from the National University of Singapore, they noticed that for simpler tasks, those super long reasoning chains are just completely unnecessary.
It's like using a sledgehammer to crack a nut.
Exactly. Like, why use a supercomputer to figure out 2 + 2 = 4?
Right. You don't need a 5-paragraph essay to explain that.
Nope.
So how did they actually turn this insight into a practical solution?
Well, they developed this technique that they're calling CoT-Valve.
CoT-Valve?
Yeah, basically it allows them to adjust the length of the reasoning chain based on the difficulty of the task at hand.
So it's kind of like a dial.
Yeah, exactly. Like a dial controlling the verbosity of the AI's thought process.
I like that analogy.
But the real question is, how do you actually implement that? We're talking about manipulating the internals of a complex AI model here.
Right. That's not exactly a simple tweak.
No, it's not. So what they do is they identify a specific direction within the model's parameter space.
Parameter space.
Yeah, think of it as like all the possible settings that control how the AI behaves. And by manipulating the intensity along this direction, they can make the AI generate longer or shorter reasoning chains as needed. And they actually use some pretty sophisticated techniques to do this, like LoRa.
LoRa.
Yeah, low-rank adaptation. It's a way to fine-tune these models more efficiently.
So they're basically finding a way to tweak the model's internal settings to make it more concise when it needs to be?
Exactly.
But how do you even test something like that?
That's where their mixed chain dataset comes in.
Mixed chain.
Yeah, it's specifically designed with multiple solutions for each question, and each solution has a different length of reasoning.
Ah, clever. So they can really fine-tune that adaptability.
Exactly.
So the big question, did it actually work?
Oh, it worked. And they didn't stop there. They actually came up with 2 enhanced strategies, too.
2?
Yeah. CoT-Valve++ and CoT-Valve +P.
Okay, break those down for me.
So CoT-Valve++ gives you even more precise control over the reasoning length. And then CoT-Valve +P actually progressively compresses the reasoning chain as it goes.
So they're not just shortening the chain, they're actually optimizing it step by step.
Precisely. And to measure how well all this is working, they introduced a new metric called ACU.
ECU.
Yeah, accuracy per computation unit.
Interesting. So it's not just about getting the right answer anymore. It's about getting the right answer efficiently.
Exactly. And when you're dealing with these massive models, efficiency is everything.
Yeah, those computational costs can get out of control.
No kidding. So the big question is, did CoT-Valve live up to the hype?
Well, let's hear. What were the results?
They were pretty impressive. Across a variety of models and datasets, they found that CoT-Valve could shorten those reasoning chains significantly.
Okay.
But here's the kicker. It either maintained or even improved the accuracy in many cases.
So the AI's explanations were shorter and they were just as accurate, if not more so.
Yep. Pretty incredible, right?
It is. And you mentioned earlier that there were some other interesting findings that came out of this research.
Oh, yeah. There are a few things that really stood out to me.
Well, I'm all ears.
Okay, so one of the things that really caught my eye was that on the easier data sets, those shorter reasoning chains actually outperformed the longer ones.
Wait, so being more concise actually led to better results?
It seems that way.
Yeah.
Yeah, for those simpler problems, it's almost like those longer chains were introducing unnecessary complexity.
So the model was kind of getting lost in its own thoughts.
Yeah, exactly. Wandering down these irrelevant paths and potentially even introducing errors along the way.
So shorter, more focused reasoning actually helps the model stay on track.
That's what the data suggests. And, you know, this has some pretty big implications for AI development, especially when you think about efficiency.
Right, because training these massive language models already takes a ton of resources.
Oh yeah, it's a huge computational cost.
If we can get the same or even better results with shorter, more efficient reasoning, that's a game changer.
Absolutely. It really speaks to this broader shift we're seeing in the field. It's not just about building bigger models anymore.
It's about building smarter models.
Exactly. Models that are more elegant, more precise.
And there was another observation from the paper that I thought was really interesting. You mentioned that not all reasoning chains are created equal.
Oh yeah, that's a big one.
What exactly did you mean by that?
Well, it seems that some reasoning chains are just inherently easier for the model to learn from.
Even if they all lead to the correct answer.
Right. Even if two different chains get you to the same conclusion, one might be way more convoluted for the model to actually understand.
It's like the difference between a clear, well-structured explanation and a rambling, confusing one.
Perfect analogy. Both might get the point across, but one is just so much easier to learn from.
So we need to be more strategic about the kind of data we use to train these models.
I think so. It's not just about quantity anymore, it's about quality.
We're not just teaching the AI how to think. We're teaching it how to think well.
That's a great way to put it. And this raises some really interesting questions about how we design training data sets moving forward. Can we focus on those more effective, more easily learned reasoning paths?
That's a whole new area of research right there.
Oh, absolutely. And, we've talked a lot about math problems, but I'm curious, what about the broader applications of CoT-Valve?
Yeah. Where else could this be applied?
I think the possibilities are pretty much endless. Anywhere you need an AI to think and reason, CoT-Valve could potentially make that process more efficient, more adaptable.
Okay, give me some specific examples.
Sure. Well, imagine using it in AI systems for code generation.
Interesting.
You could have an AI that writes really concise, efficient code snippets when you need something simple.
Okay.
Or it could generate much more elaborate, well-documented code for complex projects.
So it's like having an AI coding assistant that knows when to be brief and when to go all out.
Exactly. And it doesn't stop there. Think about scientific research. An AI that could help you analyze data.
Okay.
And depending on what you need, it could either generate a really concise summary of the findings,
right,
or dive into the intricate details of a complex experiment.
So instead of drowning in data, you'd have an AI helping you navigate and pull out the most relevant insights.
Exactly. And this could even apply to creative writing.
Right.
Think about it. An AI that could help you write anything from a short, impactful story to a sprawling epic novel.
Wow. And all while maintaining a consistent style and voice.
That's the idea.
That's pretty mind-blowing.
This research really opens up a whole new avenue for exploring how we control and optimize AI's cognitive processes.
We're going way beyond just teaching AI what to think. We're actually starting to teach it how to think effectively.
And that's incredibly exciting.
It really feels like we're entering a new era of AI.
I think so too. It's not just about raw power anymore. It's about finesse. It's about control. It's not just about raw power anymore. It's about finesse. It's about control.
It really feels like we're entering a new era of AI, where it's not just about raw power, but also about finesse and control.
I completely agree. And what excites me most about CoT-Valve is that it hints at a future where AI systems are not just capable, but also deeply aligned with human needs and preferences.
We're not just building tools anymore. We're building partners. Collaborators that can adapt to our way of thinking and working.
That's a great way to put it. And I think this focus on aligning AI with human needs will become increasingly important as these systems become more integrated into our lives.
Especially when you consider the ethical implications. You're essentially giving AI more autonomy, more control over its own thought processes. That comes with a certain level of responsibility.
Absolutely. We need to ensure that these systems are not only efficient, but also transparent and accountable. That we understand how they're arriving at their conclusions and that those conclusions align with our values.
It's like we're not just teaching AI to think, but also teaching it to think responsibly, ethically.
Precisely. And that's going to require a multidisciplinary effort, bringing together not just computer scientists, but also ethicists, psychologists, and philosophers.
It's a fascinating challenge, and one that I think this research is helping us address in a meaningful way.
I couldn't agree more. This paper is a great example of how we can start to bridge the gap between AI capabilities and human values.
So as we wrap up this deep dive into CoT-Valve, what's the one key takeaway you want our listeners to walk away with?
I think the most important takeaway is this CoT-Valve represents a paradigm shift in how we approach AI development. It's not just about building bigger models, but about building smarter, more efficient, and more human-centered models.
It's about moving beyond brute force computation and embracing the elegance of concise and controlled reasoning.
Exactly. It's about building AI that doesn't just solve problems, but solves them in a way that aligns with our values and our understanding of the world.
Well said. And on that note, I think it's time to wrap up this episode of AI Paper Podcasts.
It's been a pleasure diving into this research with you.
Likewise. And to our listeners, thank you for joining us on this journey of exploration. We hope you found this deep dive informative and thought-provoking.
And as always, keep exploring, keep questioning, and keep pushing the boundaries of what's possible with AI.
Until next time, happy researching.